Thank you for the sorry. Thank you for the introduction. Good morning, everyone. My name is Jiaxin Ling, and I'm from the Ballet School of Sustainable Construction, University College London. And today I'm very happy to share our research, augmented reality in the digital preservation of cultural heritage case study in Poland. And this is my outline. The first one, the background. We all know that cultural heritage is very useful to overcome present and the future challenges. And on average, more than 20% of the building stock in the EU is built before 1945, and a significant percentage of it has certain degree of heritage value. And there is a number of challenges and dilemmas facing the preservation, restoration, reuse, interpretation, and management activities in heritage buildings. And you can see the picture on the right side of the slide, such as accessibility, engine comfort, climate resilience, and resources. And this is a project I'm working on. It's called Inherit. It's an EU co-funded project that addresses the challenges concerning the preservation, restoration, and the management of cultural heritage buildings. And the overall vision of Inherit is to co-design, develop, demonstrate, validate, and replicate next-generation solutions for sustainable, inclusive, resource-efficient, and resilient cultural heritage using some leading-edge information and communication technologies. And you can scan this QR code for more detailed information. When it comes to the current status of the heritage preservation, and the traditional heritage preservation methods use manual inspections and documentation, and it relies on regulation-driven processes and domain expertise using like historical photos, drawings, and some historic written records. And there has been a digital transformation which transforms the traditional heritage preservation to the modern heritage preservation. Like we can use the H-beam, also known as a heritage beam, to integrate the data and the information. We also use IoT-based sensing, and we use VR, AR-enabled visualization and interaction for better heritage presentation. And based on the VR, AR applications, there are many three purposes that in the existing literature. The first one is the tourism. The second one is the education, like make historical content interactive, accessible, and engaging for the general public. And the third purpose is the reconstruction of the heritage. So the problem is AR is often treated as a tool for interpretation other than intervention. So the research problem is how AR can be repositioned from a communicative or educational medium to a functional platform to support better decision making. So our objective is to propose a digital framework that can integrate AR with multi-source data to support informed decision making in heritage building preservation. And we also want to implement the framework in a real-world heritage building and validate its effectiveness. So here comes the overall framework of our study. The input is like includes the H-beam, the multi-source data, and the output is a reproduction of renovation strategy, the maintenance advice. And in this process, we use Unity and Microsoft HoloLens 2 to construct the AR scenario. Here are the 4 steps of our study. The first one is the raw data collection, such as H-beam and photos, point cloud data, the building information. The second step is the AR scenario construction. And after that, we use Microsoft HoloLens 2 for immersive interaction. And finally, we apply our system in 2 pilots. And in this study, we focus on the first one, the heritage building in Poland. Based on that, this is system architecture. There are 3 layers: physical layer, data layer, and application layer. Physical layer, some equipment like AR equipment, sensors in buildings. And the data layer is mainly for data transfer from different files and systems, data interoperability, and data visualization. And the third layer is an application layer for different end users and stakeholders, and for AR-based maintenance and renovation. This is the AR device we use in our study, the Microsoft HoloLens 2. Here comes the more detailed technical roadmap of our study. For the engine, we use Unity and use C# programming languages. We also use the different SDKs and APIs like MRTK, Windows SDK, and above this we have UI, and we have data management, graphics, and version control. As I said before, Inherit will be demonstrated and validated in 8 real-life cultural heritage sites across 8 countries in Europe. And in this study, we will focus on this one, the heritage in Poland. And firstly, we have collected HBeam and point cloud data from our project partner. And after we have this data, we imported these files into Unity, and the picture on the right side is the HBeam in Unity. And this is the video of the developed platform in Unity. First, when you click on the platform, you can see the project overview and some pilot information like names, location. And when you click the view details, there are several different functions. You can view different architectural views of the model, and also you can see the point cloud data of the heritage building. And the third one is the maintenance information. When you click on the model, like click on the crack, you can see some basic information of the crack. And the fourth one is the renovation scenario. And we predefined 3 different renovation scenarios in the platform. And when you click the before renovation and after renovation buttons, you can compare the before and after renovation effect. Based on this virtual platform, the AI environment is also created and tested in Unity. And during this process, the main toolkit used is the MRTK called Mixed Reality Toolkit. And this is a small video of what we have developed in Unity. And the left is in the scene tab, and the right is in the games tab. So the first one we developed in AI environment is the maintenance in AI environment. The picture on the left side of this slide is, as you have seen, the maintenance information in the virtual platform. And in AI environment, we are interacting with structures. Maintenance information will be presented to different users. And this video is maintenance information in AI environment. You just need to interact with the structure, and the information will be given. And the third function we developed in AI environment is the before and after renovation in AR. And we converted the textual renovation plans into 3 predefined renovation scenarios. Includes crack repair, add balcony, and remove graffiti. And this video shows the before and after renovation in AR scenario. You can click on these buttons to compare the before and after renovation effects. And we also try to integrate IoT data in AR environment. And this picture shows the raw IoT data from our project partners is in the Excel file, and includes 6 types like temperature, carbon dioxide. And we organized it in 4 forms in the AI environment: 1 day, 1 week, 1 month, and 3 months. As for the validation of the study, first we have organized an online inherited project workshop, and we have designed several open-ended questions. And most of the participants think our functions can be useful for the maintenance and renovation of the heritage building. And this table shows the comparisons with existing literatures. And the biggest advantage of this study is the integration of real-time data and the presentation of renovation scenarios and preservative information. So here comes the conclusion and the future works. The innovation of this study is to propose a digital framework that integrates AR with money source data to support better informed decision-making in heritage building preservation. And then the findings is that AR-enabled method can not only support practical heritage preservation and renovation efforts, but also facilitates the collaboration and informed decision-making among different stakeholders. But there are also some limitations of these studies, such as because we rely on the Microsoft HoloLens 2, and inaccuracies in the data may also affect the inaccuracies of decision-making in the AR environment. And in some more complex and complicated scenario, AR environment also relies on a more detailed attribute model. By the way, we are also working on, because we all know that LLM, large language model, is very popular in everywhere, and we try to integrate LLM into heritage preservation, and we use the GPT-4o API as the interface, because we all know that different countries have different codes and regulations for heritage building preservation. So we want to use different prompts to provide corresponding recommendations in accordance with the regulation of local countries. And this is what we have done. It's just an initial step. When you input this, we can generate some maintenance recommendations. And in future works, we want to integrate this function into the AR platform. So this is all my presentation. Thank you. And this is our research group in University College London, led by Professor Weiwei. And you can scan this QR code to join us or collaborate with us. Thank you. Thank you very much. That's all.